Before starting my presentation, actually, now I am thinking all of you will be, all of you may correct my presentation, because after the Professor Pillar some beautiful and informative lectures based on how to prepare presentation. So I am sorry to say maybe I cannot follow according his. So maybe next time. Good afternoon, everybody. And today my presentation will focus on pattern of fluorescence associated with citrus peel defects. Actually, this is part of my PhD research work, as some of our new members here. So today, in the beginning, I will describe more about the fluorescence imaging system, my PhD main topics, fluorescence imaging based system for detecting defects of citrus. And today I will present partly from my research, but before this, in the next 2 or 3 slides, I will describe about what is the fluorescence imaging system, and then I will discuss about the importance of identification of fluorescence cause, and then describe about some findings behind the fluorescence emission from undamaged appearing citrus, as well as I will tell about the significance of these fluorescence types was to fruit quality. So this is my today's outlines. And next, background. Actually, the citrus grading system in Japan, so far they just citruses into quality categories by inspecting parameters such as size, shape, color, sugar content, acidity, etc. However, the citrus that contain visible defects such as rot, damage or injury parts, whose color are slightly different from the healthy parts, are still being detected manually before and after grading operations. This is because of variation in defect pattern, size, position and color. So attention should be paid to the development of the automatic detection of defective citrus in order to reduce the labor of grading and ensure the reputation of farmers' brand as well as supply quality citrus to the market. And hence, we will follow the fluorescence based system. So here I will talk a little bit about what is the fluorescence phenomena. According published reports, most of the citrus peel contain substantial quantities of fluorescent substances, especially flavonoids, and this the citrus peel or defective parts of the citrus peel fluoresces in the visible region of the spectra when excited by UV light. If you see here, when excited by UV light, the damaged or defected area fluoresces like greenish color. So that means fluorescence can be visible in the visible region of the spectra. And from this short video, we can we will be clear about what is the fluorescence reaction or phenomena from citrus surface. So when we excited by UV light, here you can see the damaged or defected area fluoresces. So greenish fluorescence from the defected area we can see. So this is the actually phenomena of fluorescence imaging based system. So due to the presence of fluorescent substances in the citrus peel, a wide variety of citrus can be detected by using fluorescence imaging system, and therefore in our research we are focusing on fluorescence imaging based system to pass the fruit through a darkened room on the packing line to detect the defective citruses or rotten citruses. And this is the actually layout of the proposed machine vision system. And if you see here, the system illuminates the fruits on the moving conveyor with white and UV LEDs, and acquire or develops color and fluorescence images simultaneously. And this fluorescence images was kept stored for further image processing to detect the defects. However, during processing numerous lots of fruit, we noticed that apart from damage or rotten fruit mainly caused by biotic factors, there were some citruses that fluoresces and detected by the system, even though their external appearance was fresh or normal to the naked eye. So how the elimination of this fruit early not only improves the quality of the fruit but also acts to limit the speed of the peel wells through the entire packing line. So it is important to understand and explore the factors responsible for causing fluorescence signature. However, yet no research has been done to examine this. In addition, the identification of causal regions for fluorescence may help both growers and packing house operators' perspectives. With the tool needed to eliminate the poor quality fruit, they can set some criteria for out of standard fruits, as well as take necessary steps to reduce peel damage, and as well to provide some information or some idea how to manage the fruit to maintain the blemishes on the peel at lowest possible level. Therefore, the objective of this work was to identify the physical causes for fluorescent signatures, and then what the significance of these fluorescent types was to fruit quality. And to do this, the methodology was, after processing numerous lots of fruit, we collected the sorted citruses, and then we separated into, we examined whether the system detected only the rotten citruses or the citruses that appeared undamaged to the naked eye under visual light. So we found among sorted citruses, 20% citruses that appeared undamaged by naked eye and not culled by the packing house workers. We found 20% among sorted citruses, this type of fruits. And then we, for further experiment, from these samples, we collected around 35 kilogram samples to check and to find some possible regions. What are the regions behind the fluorescence emission for this type of fruits? So we check by UVA system, and then we check by digital microscope system. And here, if you see from this group of citruses, we can see the color image. From the color image, we cannot see any damage, any type of damage here. But when we accord the fluorescence image, we can see there are some defects or some fluorescence area, like this, like this. So then the randomly collected samples were tested in the laboratory by using UV illumination system, which is composed of 4 fluorescence lamps and with a VGA format CCD camera to identify the fluorescence regions of each sample. So after identifying the fluorescence region of each sample, then we use the digital microscope system to acquire inverse color and fluorescence images. From here, you see, to acquire inverse color and fluorescence images for closer examination. And here some results and discussion. We make categorization. The first categorization follows slight physical damage. And this type of fluorescence pattern was observed among 1/5 of the samples. So, and this categorization was further divided into following these 3 categories: thin scare, whole and flow, shrunk at calyx. And it is really difficult, if you see, by the workers or by manually to sort this type of fruits. because it's very hard or impossible to see this type of defects by eye. And also, this type of damage gradually weaken the peel structure and later develop the damage, and that can be visible. And this thin scar can be created mainly by mechanical equipment. For example, during various type of orchard operation or cultural practices, or for example during picking, the rough handling of the fruit with cutter bar or knife may create thin scars on the surface, and that thin scars collapse the weld cells. That's why the weld comes out, and that weld can be visible under UV illumination. And we can see the strong fluorescence from this type of pattern. And the pixel size, we observed the lowest pixel size around 150, and the minimum length of the scratch we observed from the detected samples was 6 millimeter by the system. And the second one is hole and flow. The main contribution to create the hole is the wind we identified, because during windy period, when the fruit has possibility to rub against the tree thorn or sticks or even twigs, so they make hole, and after creating hole, the fluorescence well comes out and increase the whole area. And if you see, there is in the whole area, the fluorescence is fairly evident and gradually decreased. And sometimes the hole may be created inside of the packing house, because sometimes in packing house the fruits are cleaned by the brush. So this brushing equipment may create holes sometimes on the fruit surface. And we observed the system detected the minimum diameter of the hole was 3 millimeter detected by the fluorescence imaging system. And the third one is shrunk at calyx. And sometimes squeezing or shrinking near the calyx may display the fluorescence. And if you see the color image, we cannot see any sign of disruption or damage to the peel. However, under UV illumination, we can see strong fluorescence. But it is very difficult to find the proper region for this type of damage. But we think, or according to experience of packing house members and growers, this may cause due to gravity force or more pulling force during harvesting. You know, in Japan, most of the fruits are harvested manually. And next group is rubbing against decayed fruit. Sometimes you see here the decayed fruit like this. When after harvesting, the fruits are packaged into the container and transported to the packing house. So in the container there are this type of severely rotten fruits, and these fruits, you see, juice comes out and some dust, they are collision each other, hitting each other, and make some pieces of dust. And this piece of dust and this oil juice, when mixed with the neighbor or surrounding non-decayed fruits, they are fluorescent. Like this here, this fruit is fresh, but on the peel, some juice well from the rotten fruit, and we can see the fluorescence. However, after washing, the fluorescence disappeared. And secondly, you see this is some dust, not the fruit peel itself. It's from here, some dust pieces attached on the surface, and this dust is fluorescent. However, after wash, we cannot see this. So this is another region for fluorescence pattern. And the third one is rim puffing. Sometimes the floating skin or the excess space between peel and pulp may create some injury, small depressions on the peel, and we can see the fluorescence. And this green spots, this is the main problem in the fluorescence imaging systems so far. Like we observed around almost half of the samples, they had this type of fluorescence pattern. And we observed this fluorescence has this type of fruits. The outward appearance was yellow greenish color, and the greenish color only shows the fluorescence. And the fluorescence actually like a scattered type of fluorescence, and the intensity of fluorescence not like this previous groups. So we think the presence of chlorophyll may cause the fluorescence, and so far it is not well understood what are the precise reason for this type of pattern. But according citrus industry representatives and farmers and some horticulturists, we thought this may be caused variety of factors like climate or like nutrition deficiencies or lack of sunlight. And another one, actually, this is belongs according to citrus industry representatives. Sometimes prior to harvest, the growers spraying agricultural chemicals. So these agricultural chemicals sometimes may display the fluorescence, espalage type bluish color fluorescence. However, in my experiment, I did not observe this type of fluorescence this time, because these fruits were collected in the late season or peak season, and these fruits from the early harvest fruits. And then this is the percent of observation of each pattern, where we can see the green spots has the major contribution, and the slight physical damage and rain puffing, both are same contribution around 20%, and the lowest contribution is the rubbing against decayed fruit. And then we checked the same fruit. We checked the what are the responsibility or significance of these fluorescence types on the fruit quality. And we see this thin scale and whole, after 1 week, they become rotten, and the injured area became more visible, and the fruit, you see, the totally rot. And for shrunk, after 2 weeks, we see the affected area become visible. And for in case of rough with decayed fruit, within 1 week, we can see that the affected area increased and the damage to develop. And green puffing, it's actually within 1 week, the damaged area, depressed area becomes like this, from darkish to black lesions created. But for this type of case, the green spots, after 2 weeks, actually we did not see any decay, but the green spot area, like some soft, they become soft and become apparent. However, this group's not so critical with the previously group to sort out before. But considering the cosmetic look of the fruit, as well as for long-term preservation, might be better to remove early. In addition, we put one rotten fruit, severely rot fruit, in the fresh fruit container, and we observed how it affects the fresh fruit. And we see after 2 weeks, around 50% of the fruit affected by this rot fruit. So I have to keep. And the conclusion is we study UV illumination and digital microscopy-based system to observe the possible reasons why fluorescence is present in fruit that appear to be undamaged by eye. And we observed that beyond biotic causes, there are defects associated with slight physical damage, presence of green spots, puffed skin, and contact with rotten fruit or damaged fruit. And the stress experiments with the 4 classes indicated that, except for the green spot class, the injured area expanded quickly and caused the fruit to rot within a week. And these findings can help the packing house members to answer growers' question as to why fruit are downgraded, and enable the growers to understand the different unseen injuries, as well as both sides can set criteria for out-of-standard fruits and make some possible remedies to minimize losses in the future. Thank you for your kind attention, and I'm sorry I was over 3 minutes. Any question and comment, please, welcome.
There. Keep there.
Yeah.
Any question?
Okay, sir.
In your presentation, you also showed that you got some fluorescence when the oil from the broken skin had gone onto another fruit
yeah.
or the dust. In a packing house situation, where would you suggest the fluorescence scanning take place? Before washing or after washing?
Actually, these fruits after washing, and this fluorescence imaging system at the final stage. Suppose after washing, with some wax material or some water, with water, and then like this make some manually sorting, and then after that maybe internal properties detection, and final stage is the machine vision system for detecting sorting fruits. So actually I heard before powering on the conveyor, the fruits from the orchard, the fruits being brought to the farmer's house, and first 2 days they sort by themselves. After that they've sent to the packing house, and packing house may wash and then they put on the conveyor. So, but still that type of fruits available on the conveyor. So when the final sort out and the farmers say saw many of his products, citrus fruits on the damaged part area, so they asked the packing house operators why these fruits not damaged or defect by eye. I cannot see why your system identify. That's why we did this experiment. And I think also they use some brushing method like some towel to remove this, but it's still not possible because when I wiped out, I thought I need force to remove this.
Anyone else?
Thank you. In all cases, how can you explain more how UV light can make things that unseen and then invisible? I mean, the interaction between light and chemical or something. Can you explain more about that?
Can you explain? Please, one more.
Yeah. After excited by UV light, so you can see that
Fluorescence.
rules or chemical. How can you explain that? What happened with the fruits, so we can see that thing?
I cannot actually recognize yet. So after excited by UV light,
Yeah.
and then the fluorescence comes.
Yeah, the bruise or the chemical.
Yeah, the bruise actually, as I mentioned before, the citrus peel, they are composed of various types of fluorescent substances, and especially heptamethoxyflavonoid. And these chemicals has one properties is when it is injured, and then the juice, if the juice comes out and you excited by UV light, you can see the greenish or yellowish fluorescence from that properties. So I think when it make damage or injured area, it fluorescence, and or the juice on the surface, it also make fluorescence. But I don't think on the conveyor how can we differentiate or.
Yes, that's when the compound reflect.
Yeah, the compound itself reflects the fluorescence. I
Also
think.
the chemical can also reflect the UV light.
Yeah, that chemical, I heard from them like copper or mancozeb. They spraying copper mancozeb to prevent from the melanos or some brown rot or brown spot, to prevent this type of from this type of mites or pathogens. They pushed spray copper on mancozeb, and this type of agrochemicals has properties to reflect the bluish fluorescence, not the green or yellowish, like bluish color or whitish fluorescence. But actually in the real case I did not observe this type of.
Can you explain what fluorescence reaction is?
What fluorescence reaction? That means since the spectral or what?
Mechanism. Why fluorescence? Why light come out?
Ah. What? Right? Yeah, the mechanism, I think, since if I put here, suppose this is the orange, and here is the defect. If we put the UV light here, UV, suppose this is camera, from here, some reflection. So this reflection has like this. Suppose this camera, or color camera. Suppose from 400, like 700. So here, suppose 500 to 600. So I think this properties has the greenish color properties, and when light excited, and that wavelength more than 400 from here, reflection, light reflection. So this is color camera, so it can capture this greenish or bluish color.
You may ask about that.
Yeah.
What fluorescence is in the difference.
Yeah.
So you have to. So you may prepare. You have to prepare the what fluorescence reaction.
Also, we analyze some what are the substance actually. So far we analyzed from this part, this is actually rotten peel. So we analyze this substance, what substance actually here. So suppose heptamethoxyflavone. This chemical or this substance has properties. When we can excite by UV, you can see the reflection in the visual. So that means these properties show the fluorescence. But in case of lemon or yuzu, we cannot use this same mechanism because when we injured, we cannot see the fluorescence. And we now examine the substance of the lemon peel or yuzu peel, and we found some puramine, like puramine type of species product, and we examined that was substance. If we excited the UV light, and here fluorescence actually near 400 or around 390 to between 410. So we cannot see the fluorescence reaction from lemon and yuzu by using fluorescence imaging system.
Not only UV, not only visible, fluorescence reaction behind that, the some shorter wavelength, longer. So you may have to, and then why longer? How many longer? How many wavelengths longer? You better learn about that more. Any other question or comment? And when you present the some UV lighting device and the UV lighting framework, so how did you explain? How did you describe the strength UV light?
Based on intensity, sensei.
Intensity. How do
Yeah.
you
Like for my case, from when I bought the EV blacklight, I found the intensity
how did you measure?
like some I forgot EV LED flux meter.
Unities.
Yeah, flux.
Flux.
Yeah,
Yeah.
FLUX.
Those kind of things, and how you describe the brightness of the fluorescence reaction. That is technical. You have to show something. Next one. So half a year later, you defense. Defense is 1 hour. Okay? So many professors giving the question. You have to defend. Can you? Yeah.
Yeah, I'll try.
Anything else?
Why?
Transforming
Yeah.
can show many kinds of damage the fluorescence. And there is a pie chart to show how many percent.
Yeah.
That is based on
Oh,
how many
sorry.
oranges
Actually,
reading
I used 35 kilogram sample randomly, and this means around 330 sample. Okay, and then I take mesh from these 330 samples and then distribute into the pie chart. And this sample collected 4-day experiments and randomly, morning, mid-time and evening times after grading by the system.
Okay? Okay. Thank you very much.